We're continuing on with inverse variation, and I'm kind of set in my way in how I like to teach inverse variation, but if you remember what we did it ages ago, or it feels like ages ago, we did what's called direct variation, which is of the form y equals kx. Well, the difference with inverse variation, or being inversely proportional in some of the keywords, is y equals k divided by x. So as we're looking at this situation here, what they did is they solved for k, and think about, well, how can you solve for k? Is to multiply the x over. So it's y equals x times, k equals x times y. So when we're looking at this problem, it's not necessarily that they ignore the k, but if we're inversely proportional, I guess both these situations would be solved for whatever k is. But anyway, if you're looking at this first exercise, in order to balance on a seesaw, they must adjust the distance away from the fulcrum, which is that balancing point. I don't know if you're familiar with that word, according to their weights. And so we have this situation, and they're inversely proportional to each other. So if somebody weighs more, they need to be closer to the fulcrum compared to somebody who weighs less. They need to be further away in order to balance them out. So if we look at this situation, how far from the fulcrum must a man who weighs 160 pounds sit if his 50-pound son is sitting 16 feet from the fulcrum? So if I were to teach this the way I'm sort of set in my way of y equals k divided by x, what I would think about is setting up a situation where the 50-pound son, 50, is equal to k divided by 16, and then I would solve for k. And the way I would solve for k is by multiplying the 16 over, and you're welcome to use a calculator. 50 times 16 is 800. So this is how I would traditionally teach this. So then I would go back to my equation, and it's y equals 800 over x. Let's see, and I put 16 feet. So this might be a little bit confusing, but the way I had it set up is I would put 160 in for y is equal to 800 over x, and then I could cross multiply, so I'm looking at 160x is equal to 800, and then you would divide both sides by 160. And you would get that x needs to equal 5. Which I don't know if you're familiar with seesaws, but heavier people have to weigh closer than the lighter people have to sit further away in order for it to just stand straight across. Okay, so if the boy's 80-pound cousin now gets on the seesaw, then how far must the cousin sit from the fulcrum if the boy does not change his position? Kind of wish they were a little bit more clear on this one, but the whole thought process is the man gets off and the cousin is now on. So let me teach the other way that you can do this. So this is not typically how I teach it. I'm going to use this formula up here. So we know the weight of the cousin's 80. We don't know his distance, but we do know that the boy still weighs 50, and his distance is still 16 feet. So yeah, this would probably be a faster way of teaching it. Divide the 80 over, and so the distance that this cousin needs to sit, and I'm going to go to a calculator again because I don't know what 50 times 16 is, and then divide it by 80. I could probably figure it out. It's 10, and to give units would be feet. Quick way to do it would be 16 divided by 8 is 2, so it's 50 times 2 divided by 10. Anyway, you can use a calculator. So again, I want to teach this sort of the way I would do the problem first, and then I can talk about how this problem would probably be solved otherwise. So x and y vary inversely. A lot of times we do y equals k divided by x. So if I'm going to do the problem my way, I would set it up as 9 equals k divided by 2. That's this first situation, to multiply that 2 over. So then what I would do is go back to this problem and write it as y equals 18 divided by x. And now that we know that x is 6, I get that y equals 3. So again, that's just how my brain works. I've been teaching this method for a while, because then you don't, I guess it really doesn't matter if you flip it around, but it's just how I would approach the problem. So I'm looking at 12 equals k divided by 3. When I multiply that 3 over, 3 times 12 is 36. So I can go back up here, and so it's y equals 36 divided by x. As I'm looking at it, it'd be 6 equals 36 divided by x. And if I cross multiply and then divide, I'm going to end up with 6 equals 30, or sorry, x equals 36 divided by 6, which does come out to be x equals 6. And just for anybody that likes the other method of x1, y1 equals x2, y2 with inversely proportional, you'll get the right answer. So we're looking at 8 times 10 equals 2 times y, and you can divide that 2 over. 8 times 10 is 80, divided by 2 will give you 40. So there's just another option for anybody that wants to do the problem that way. So here's another one, just kind of crossed it out on accident, that w and z vary inversely. And so what this means, if I were to set it up, I just like the larger variable to be, you can actually switch it around. But what this means is, if we set up the problem this way, is if we increase w by a certain amount, what happens is that z gets divided by more. I'm trying to think of another way of thinking of it. Because, let me put it this way, if we double w, we can't just put a 2 in here. We would have to multiply this other side by 1/2. Now, we've talked about it before, that, how do I want to phrase it? That dividing by 2 is the same thing as multiplying by 1/2. Well, none of these situations have 2 in there, but there's a situation with 3. So if we multiply w by 3, then z would be divided by 3. Trying to think of another way of explaining it. Maybe a quick explanation is that wz has to equal w2z2. So thinking about, we can't just randomly throw in a situation where we triple w unless we at the same time divide z by 3, because now they would be equivalent. That might be a bad explanation as well, but the correct answer is option 3. So I do apologize if you're trying to learn this at home. Hopefully in class makes more sense. So here's another situation where we vary inversely, and if you switch the variables around, it actually is not that big of a deal. But this is true to pry a nail from a piece of wood, and looking at the variables, it looks like I'll use F for force, and I don't know, I'll use C for crowbar. And so if we set this problem up of 15 pounds of force equals a 6-inch crowbar, and then we multiply that 15 over, that's 15, 30 times 3 would be 90. Double check with the calculator. And then I can go back to my equation of 90 divided by C. We have an 18-inch crowbar. 90 divided by 18, which I'm not exactly sure. There, give me an answer of 5 pounds of force. again, this is not the only way to approach the problem. I don't want you to feel like you have to do the problem my way, because what you could do is set it up as 6 times 15 is equal to f times 18, and then divide that 18 over, which is essentially what I did. It just, my brain doesn't work that way. You still get the right answer. Here's another situation where we're varying inversely. Even if you're not very good at reading, I hope you can identify some of the key words. 45, if it takes 45 minutes to drive home in rush hour traffic when we're moving 15 miles an hour. So however you want to set it up. This is actually a distance equals rate times time problem. But the difference is that what they're doing is it looks like they're solving for a different variable, because the distance stays the same. So I'm just confused on which one for a second. And that's the thing, is it doesn't actually matter which one of these variables. Like if you write d divided by r equals t, or d divided by t equals r. That's why these words might seem weird. But that's where the other formula actually comes from. If you prefer the method where they write it out, that 45 times 15 is equal to 50 times, you just might not really know what you're solving for unless you read this carefully, that you're solving for time. So the reason why you can skip this middle step of how I've been teaching it is the distance is the same between work and home no matter what. So if this is making more sense to you, feel free to do it this way. So just be careful and make sure you answer the question that's being asked. So 45 times 15 divided by 50 is it takes 13 and a half. So t is at 13.5. So the question doesn't ask how much time it takes if she's going 50. It's saying how much time does she save. So that's why I kind of went the easy route on explaining this, because typically it's 45 minutes when she's only moving 15 miles an hour. That you have to subtract off that 13.5 that it would have taken if we're concerned with how much time she saves. And it's 31.5 minutes, so she gets home a lot faster. Oops. It didn't look like an N there for some reason. Anyway, on the next problem, it actually gets you to understand the connection I was trying to make at the beginning. So sometimes people explain the problem this way. I'm used to the textbook that would explain the problem as y equals k divided by x. So that's what number one is actually asking you to do anyway. If I asked you to solve for y, I hope you would look at the multiplication problem and say, oh, I need to divide x over. So what we can do using the calculator is we can type into y equals now, oops, forgot that was still in there, 8 divided by x. Now if you're curious, you could hit the alpha x and do 8 divided by x this way as well. If you look at the graph, whoops, I forgot how much I was zoomed in, you can see what the graph looks like. Now it's not very clear where these ordered pairs are, so that's why the directions say to use a table. And I'm just going to use a few points, like -2, -4, -1, -8, -2, 1, 2, 3, 4, and -1, 1, 2, 3, 4, 5, 6, 7, 8. And maybe one more. I need to hurry up. -4, -2. And what your graph should look like is something like this, assuming I hit those points. Same thing on the other side. I'm going to do this quickly because I'm running out of time. You can double check. But why is there an error is we cannot divide by 0. In other words, there's no y-intercept.